important in managing Kubernetes. Kubectl provides access to both local and remote clusters and is essentially the primary gateway to interacting with any Kubernetes cluster. Since it's the primary command line access tool, it's important to get to know it well. By now, you've used it to deploy some data and deploy a Tomcat deployment to a cluster. However, you can use it for a variety of other methods too. We'll go over the most common kubectl commands here. Kubectl commands all share a relatively similar format and command set. Notice the patterns between the commands we'll review here and throughout the course. The kubectl get pods command lists all pods in a namespace. If we were to take our current minikube setup and run kubectl get pods, we would have one single pod listed, the Tomcat deployment that we deployed in the previous lecture. This command provides the state, how many pods are available, restarts, and the age. Let's run kubectl get pod on our local minikube. You'll notice that our Tomcat deployment container, actually pod, is right there. Don't worry about the other two, those are images I had running for later examples. Let's cut and paste the name of that pod for use in the next command. Copy that to your clipboard. If we'd like to get more detailed information on a pod or pods, we can use the kubectl describe pod command. If you don't provide this command a pod name, it will provide detailed information on every pod in the namespace in the cluster. If you provide it optionally the name of a pod, it'll only provide data on that specific pod. Let's use the kubectl describe pod command and the name of the pod that we've already copied to our clipboard to get detailed information about the Tomcat deployment. As you can see here, we have a wide variety of detailed data specifically and only about the deployment for our Tomcat. Hopefully you remember the kubectl expose port command. Remember, Docker containers can expose a specific port. We have to take that port and tell Kubernetes to expose it to the outside world. Using the expose port set of commands in kubectl, we're able to name a deployment, a pod, or a service, and expose it to the given world at a given port or a random port that kubectl chooses. We're also able to define what type of service this is. Is it an internal-only service, also known as cluster IP? Is it an externally available IP address, also known as node port? Or should we use a function of a load balancer? Those are more advanced usages we'll get into later in the lecture. However, using the type argument, we're able to specify what type of port we're trying to expose. Next, the kubectl port forward command provides you with the facility to forward a port from the local machine on which kubectl is running to the pod on the remote host that kubectl is connecting to. In our current case, since minikube is already running on our system locally, this really doesn't seem to do much different from kubectl expose. However, when you're dealing with a remote cluster and simply need to map a local port on your machine to a remote port on a given pod or container, this can be quite useful. The kubectl attach command allows you to attach to a pod to view its output. It attaches to a process that is already running inside an existing container. That's important to note, especially as we go over the next few commands. Kubectl exec will execute a command within a container. This is a very useful command for debugging and understanding what might be going on inside your containers, as it allows you bash access to containers that may not otherwise have interactive facilities. The -i and the -t options are relatively important. When running kubectl, you're able to interact directly with the process you run, for example, bash, if you specify the -i and the -t options. Look at the sample output. Understand what is happening here, because this is a command that you may use very frequently when debugging or creating complex deployments. Kubectl exec -it followed by the name of the pod followed by the command you'd like to run. In this case, bash provides us with interactive shell access onto that container. Using interactive shell access, we can then introspect processes and other items available inside that container that we otherwise would have to use other methods such as log analysis to get after. Let's use the kubectl get pod command to copy the name of our existing Tomcat pod to the clipboard. Let's use that name to use the kubectl exec command with the -it options. That way we can interact with it using the standard in as a TTY to run the bash command. We now have a bash shell within our given pod that we specified, our Tomcat pod. Remember, bash isn't the only command you can run. You can run anything that's executable within that Docker image specified in that pod. However, it seems to be the most common and most useful way of using the kubectl exec command when debugging pods. Kubernetes also provides a similar set of facilities to label pods for classification either through automated processes or for manual bookkeeping. Using the kubectl label pods command, we're able to set key value pairs on any given pod. This command updates the labels on a given resource. For example, here we're labeling our Tomcat deployment pod healthy equals false. Finally, the kubectl run command provides us with a quick and easy way of running a given image on our cluster. You'll remember we had to define a deployment file that defined a pod that pointed to a Docker image to get our Tomcat deployment to run in our cluster. While that certainly is the preferred method of deploying production applications, in certain situations, you may want to run a particular image on a cluster relatively quickly and without having to do it in a replicable fashion. The kubectl run command can be particularly useful in that case. You can provide it with an image to run, a port to expose, and other options and more advanced usage are also available. Let's use the kubectl run command. In this case, we'll use the kubectl run command to run a copy of the popular Hazelcast server. Using kubectl run Hazelcast, giving it a name, Hazelcast, specifying the image, Hazelcast, and a port to expose, 5701, gives us the ability to create a deployment with one command. Let's use the kubectl describe pod command from earlier to describe the pods running on our minikube. If we scroll up through some of our other pods, for example our Tomcast pod that's already there, we can see that the Hazelcast pod has been deployed. We were able to do that with a single command instead of having to find a deployment simply by hand. This is a convenient tool for a quick administration. These commands are simply an example of a wide variety of powerful commands that are available to you through kubectl. We'll go into more in depth further in the lecture. However, it's good to keep these two references in your bookmarks as you explore Kubernetes. First, the kubectl reference for the latest version of Kubernetes. And second, a kubectl cheat sheet that provides shortcuts to commonly used patterns in the kubectl commands. Remember, kubectl exposes nearly every aspect of the Kubernetes API through that command line tool. It's powerful and will be your friend, and mastering it will make your journey into Kubernetes all that much easier. However, that's no need to fret about rote memorization. The more important aspect of kubectl, much like anything else, is to understand what it can do for you. The documentation and reference will always be there to provide you specific details on how to do it.